Okay, so today we're going to be talking about inverses of matrices. So this is kind of one of the things that we've kind of been building towards. You need to know what the inverse is. Well, let me go back. So the inverse of something is basically its opposite, right? So when I'm talking about like inverses, if I have like 5, its multiplicative inverse would be 1 over 5, right? That basically cancels it out, and you're left with just 1. Oh, and my light went out. Low light. Okay. So, like that would be its inverse. It's basically what you would multiply something by that would cancel it out or bring it down to 1, right? So that brings up the question with matrices. Well, what is the equivalent of 1? Well, we have what we call the identity matrix, which is what you would use to multiply any matrix by to get that matrix back. Okay. The identity matrix kind of looks like this. If we're talking about a 2 by 2 matrix, it's just, it has ones as like the diagonal there, and then everything else is a 0. Now, if I open it up and I did like a 3 by 3, it would you just have ones across the diagonal, right? Everything else is a 0. That gives you the identity matrix. If you multiply that by any other matrix of the same dimensions, you would get the original matrix back. Okay. That's the matrix equivalent of 1. So basically, the inverse of a matrix is what would be a matrix that would produce the identity matrix when you multiply it. Now, why do you need to do this? Well, it's going to come into role. It's something you need to do systems of equations. That's what you have to do in secondary 2. It's a row reduction using, you have to use the inverse, unless your teacher's nice. Let's use a calculator, which I mean is always possible. Who knows? But anyway, let me show you how this is. So I'm going to show you how to do it by hand, but obviously this year we're letting you guys use the Desmos calculator. So let me show you how this works by hand, and then we'll show you how to use the Desmos. So to use or to do it by hand, you have to find the determinant first. So like if I'm doing number 2 there, I would do -4 times 3 is -12, and then I'd minus -6 times 2, which is also -12. Okay, -12 minus -12. Actually, let's not do this one. JK. That one doesn't work. Let's do this one right here. So 9 times 10. I'll show you why that doesn't work in a second. So 9 times 10 is 90, and then minus 11, -11 times 2 would be -22. So that would actually be 112. Okay, so that's the determinant. So to get the inverse of the matrix, you're going to use the determinant as a scalar basically, but you're going to do the inverse of it. So you're going to do 1 over 112. So you move it across the fraction bar, and then you're going to multiply with the matrix, but you have to change a couple of things. You're going to switch the A and the D, those two things. So they switch spots. So you'd have 10 at the top and 9 at the bottom, and then you change the signs of the B and C. So it become positive 11 and -2. Okay. And then you just multiply that through, and the resulting matrix would be your inverse. Okay. So you'd multiply 10 by 112, 11 by 112, or 1 over 112. Okay. You just multiply it through, result, that's your inverse matrix. Okay, so kind of a little bit of work, but not too bad. Okay, but let's look and do the same thing on the Desmos calculator. So we're going to do the same thing, and we're going to see if we get 112 in our denominators when we do this. So let me switch over here to Desmos. I'm going to do a new matrix, and the matrix I just did was 9, -11, 2, and 10. Okay, so there's my matrix. Now I want the inverse. So the inverse function is this to the negative 1 power thing right here. So I put in my matrix, which is A, and then I click that, and that gives me my inverse. So here's all my inverses. Now we don't want decimals. We want these to be fractions. So I'm going to come over here and I'm going to click the fraction button there. And you'll see like you got 112, 11 over, that's what 1 over 112 times 11 would be, right? Like that's the same thing. These simplified down, but like 2 to the 112 would be negative 1. Yeah, that all worked. I did it right. Yay. Okay. Now I did tell you that the first one I started doing didn't work. So let me show you why that doesn't work. And it comes down to the determinant. The determinant tells you basically if it has an inverse or not, because there are some of these that don't. And if I do negative 4 times negative 3, that's negative 12. And then the negative 6 times 2 is also negative 12. So when you minus a negative 12, then negative 12 plus 12 is 0, right? Well, what happens when you try flipping that across the fraction bar? You would get 1 over 0. You can't actually divide by 0, right? So this does not have an inverse. Does not have inverse. Okay? Because you can't have 0 as your determinant. Determinant means if a 0 is your determinant, there is no inverse. And now let's see what happens when I try doing that in the calculator. I have actually done this before. So let's see. Let's experiment. So negative 4, negative 6, 2, and 3. Okay, so there's that matrix. So B, and let's do the inverse. And oh, gives me an error. What does it say? Singular matrices do not have an inverse. So doesn't work. Ah! Okay, so yeah, again, really you just have to plug them in, and then like this is your answers right there, right? Like it's not complicated. The calculator does all the work for you. You just got to know like this is your inverse button. There are obviously some matrices that do not have inverses, so that is something you will run into. So yeah. Okay. I think that's pretty much it. Everything I need to go over because calculator does everything. Okay. If you have any questions or concerns, let us know. We're here to help and we will help you. And I'll see you out there.